now let's look at how this relates to Newton's first law of motion. Right now we are driving on the spit. Clara, can you show that we're driving along on the spit?
Got your nose in it. It's okay.
So that's gonna hopefully get us started here. So Newton's first law of motion states that an object in motion tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by an outside unbalanced force. Okay, so let's break that down. So the first thing is we know that objects in motion are moving or changing position compared to a reference point. So we talked about how objects can be in motion compared to one reference point and not in motion compared to another. So right now, my car is driving 50 miles an hour on the spit, right? My car is moving relative to the Kevin Bell Arena, which we're passing right now, to the rocks on the side, to the tsunami thing, right? So we're moving 50 miles an hour and my car is moving that way. Now I am moving, or excuse me, not moving compared to the car. I'm just sitting here, got my foot on the gas pedal, but I'm not moving. However, if you compare me also to, say, that lady riding her bike, or the boats, or, I don't know, that stop sign, right? I am moving, also moving at now 47 miles an hour, along with the car. So I'm moving in the same direction and at the same speed as my car. So remember, speed is the distance an object travels in a certain amount of time. We're going to add on, we're going to start using the word velocity. If you remember that velocity is not only the object's speed, but its direction. Because this is really important in Newton's first law, because objects that are moving want to keep moving in the same velocity that they've been moving. So that would be the same speed. Oh, I've got to slow down here because we're entering the 25 mile an hour zone. Can't keep going that fast. Got to obey the laws. Let's see. Objects keep moving at in the same speed and the same direction that they've been moving. So they want to keep keeping at the same velocity. Now, also this could mean that if an object is staying still, it wants to keep staying still. So it's not going to change that motion unless some unbalanced force comes in and interacts with it. And we talked about unbalanced forces back when we looked at forces. Okay, so again, according to Newton's first law, an object in motion is going to stay in motion, an object rest is going to stay at rest. And so right now I'm sitting still in our car. The car is not moving. Clara, can you go out the window a little bit and show that we're not moving? No, that's me.
I know.
Show out the window.
Okay. Like
not
that.
moving.
Not
Okay?
moving.
So that means that Clara and I, and Skittles, show Skittles, are not moving,
I don't
right?
see her.
Compared
Where
to,
is she? There
she's right
she
there.
is. Yeah, okay.
Compared to the car, we are not moving. Compared to the outside, we are not moving. That means our body wants to keep doing this. Now, the car, if I press on the gas pedal, the car will start moving. Now, if my body wants to stay still, the car moving underneath of me is going to make me press back into the seat. A lot of you have shown that or said that, you felt that during your field trip. Claire, do you want to get a quick video of me accelerating in the parking lot?
Okay.
So I'm going to go ahead and accelerate.
Jeez.
Did you feel that? Did you feel that? Skittles,
Yes.
did you feel that?
Yes, Skittles was like,
Is she
what
freaked
in
out?
the world?
Okay. So the opposite of that, of course, is that when I'm in motion, which I'm not in motion right now, but when I'm in motion, my body wants to stay in motion. So if the car stops underneath of me, my body wants to keep going in the direction, at the same direction, the same speed that it was going before. So we're gonna try this again. Kiddies, don't try this at home. Professional driver here. Not really, but we've got our seatbelts on. All right, ready?
Okay.
So I'm gonna speed up a little bit and then I'm gonna slam on the brakes. Claire, be careful.
Okay.
So I'm not going very fast though, but I am gonna slam on the brakes, right? Now.
Skittles fell off.
Did Skittles fall off? No, Skittles was not wearing her seatbelt.
Oh, Skittles.
So-
Poor Skittles.
Poor Skittles. So, not only did I fly forward, but the parking lot here at the middle schools, we're actually in the parking lot, so I was not out on the road doing that. Parking lot here in the middle school still has gravel on it. So when I slammed on the brakes, my wheels slid a little bit because of there being less friction between my car and the road.